today we're going to talk about radical rules. The first radical rule up at the top left corner is looking at rational exponents. And basically, we've done this one, okay? This one is the one where you could rewrite it both ways. So if you have the rth root of x to the p power, it's the same as writing it x to the power over root. So let's write down a couple of examples. Example 1. What if I gave you something like this? What if I said, rewrite this, please, as a rational exponent? Well, then, to put the 3, this 3 out, right? What's the power on this? 3. And what's the root? If there's no number here, what number is it? 2. Good job. So this is really 3 to the 3/2 power. So same thing if you were to have a variable inside. The 4th root of x to the 7th power. How do you rewrite this? X to the what? Good. 7/4 power. Good. Okay. All right, so let's go over to our white sheets. And we'll look at that first row and try those practice problems. Okay. Now I want you to look at the first one. You know, and it's all numbers. So let's rewrite this and then let's simplify it completely if we can. If you rewrite this, it becomes what?
25 to the power of 1/2.
Okay, so first off, it's 2/4, right? And then Tom simplified his fraction, which you should do. You should always simplify your fraction, right? Power over root. And then this is 25 to the 1/2. And then guys, try putting that into your calculator. See if you get a non-decimal answer and tell me what you get.
You get 5.
Good. Because this is the same as saying square root of 25. And square root of 25 is 5. Okay. All right, so let's look at the next one. So for the next one, I have 10 over, okay, well, the 10 can stay. Look at that, 125 to the 1/3 power. Well, let's rewrite this as a radical. Let's put the radical here. What's the root on this?
2.
No, what's the root?
Square.
No.
Oh.
3. Square and 2 are the same thing, right? So cube root of 125. What's the power? 1. Do I have to write that power 1? No. So now all we did was rewrite it, and then let's simplify this. 10 over, what's the cube root of 125? You don't know? Figure it out. Put it in the calculator. 5. And then, can we simplify this further? Yeah. What's 10 over 5?
2.
2. And this one is 2. All right, so back to our purple sheets. Now, instead of going down the column, we're going to go across, okay? So here, radical addition. We're going to look at the top middle. Yes? All right, so with the addition, guys, there are a couple things you need to know about this, okay? They have to have the same root, and radical. Okay, so let's write that down. When you have the same root and you have the same radical, that means everything inside the radical has to be the same, okay? Then what you do is you're just adding your outside numbers. So look at that. You don't change anything inside. You don't add the numbers inside or the variables. All you're doing is adding the outside stuff. Okay? So let me show you an example. Write down this example, please. Are my roots and the radicals the same? Yeah. So then all you're doing is just adding the outside numbers. What's the outside number here? 3 plus 2. What is it? 5. So then 5, and then just copy over that same radical stuff. 5 root x. That's it for the adding. But you can only add if the radicals and the roots are the same. So I'll show you another one then. What if you had what about this guy?
Negative 5 plus 2.
Mm-hmm. Yeah, your radicals are the same.
Negative 2.
Good. Negative 2, 7th root 7. And you can add negative numbers. That's fine. They're not always going to be positive. Okay? All right, questions about this? Sounds easy enough, right? All right, let's go to our white practice sheet, and let's see what else it could look like. Like, what other type of forms could it look like? So, instead of doing number 3 first, can we do number 4 first? I think it's a little bit easier to understand. Just the numbers. So, if I look at this, okay, they're both cube root, but wait a minute, are my radicals the same? No, inside the radical they're different, so I can't add them straight right now. But whenever you see something like this, guys, see if you can simplify the radical, because sometimes you can, okay? So look at this 2. Can you break down 2?
No.
No, 2 would just be 2 times 1. You can't get a group of 3 of anything. You can break 16. So let's see. Cube root of 16 is what? 8 times 2? Yeah? Alright, let's break it down. Since it's a cube root, I need 3 in the group to come out, right? And then 8 is 4 times 2. Don't forget to bring down that other 2. Do you agree? What else can I break down here? 4. Okay, let's break it down. Okay. Alright, so we need a group of, sorry, I just thought of it. I wanted to tell you before I forgot. 3. I have a group of 3 2s. Right? So one of them comes out, and then what happens to this one? Stays in. So what we're doing is that cube root of 16, we have to rewrite it as 2 cube root 2. Yeah? So then over here, this becomes 2 cube root 2. And then plus 5 cube root 2. Because I didn't have to change the second one, right? All I had to do is just change the first one. Yes? All right, so now can I add the outside numbers? Yes, right? Everything is the same in terms of the radicals, the roots, and the stuff inside. So when I add the outside numbers, what do I get? Good. 7 cube root 2. That's my answer. Okay? All right, so look at the first one. So the first one, they're both fourth root, but is the stuff inside the radical the same? No, it's not. So let's see, which ones can we simplify? Look at this first one. No, not first one, the second one, I'm sorry. This guy right here. Fourth root of 3x. 3 is already a prime number. Can you break it down? No. How many x's are inside here? Only one. But how many do you need in order to come out? 4. You have enough? No. So it looks like this one has to stay, right? I can't break it down. But look at the first one. Oh no. Oh no, it's happening. There we go. How about the first one?
Yeah, you can break it down.
Yeah. If you look, fourth root of 3, nope, 3 you can't break down. But the x's, how many x's do you have inside? 5. And you just need a group of 4. So, if I break this one down, I'm going to say 1, 2, 3, 4, 5. You need a group of 4. Well then, 1 comes out, right? So the 5 was already out, so bring the 5 down. One of the x's comes out, right? And then fourth root, what has to stay in still? 3, and then what? Yeah, that leftover x. We okay with that? And then the second one, we didn't have to change. It was just x, and then fourth root of 3x. Right? Sabrina, you okay with this? Just need a second. So then with this one, guys, can I add the outside numbers now? Yeah. Good look. Fourth root of 3x and fourth root of 3x. Now they're looking the same. So that means, what is this? 5x plus x is what? Not squared, because you're not multiplying. You're adding. So if you already have 5 x's and you add another x, how many x's do you have? Huh? No, you're adding. Good. This is like 1x, right? 5x plus 1x gives you 6x. And then bring over your fourth root of 3x. All right, Timlin, you okay with that? All right. Questions? We okay? All right. So then let's go back to our purple sheet. And then we can talk about radical subtraction. So subtracting. So same as adding, okay? The rules are the same. You have to have the same root and the same radical. And I keep saying radical, but it's really the stuff inside the radical, which is called the radicand. But I feel like that kind of simplifies it a little bit. Do you have a question, Tom?
So if you have two negatives, right? Then does the sign change in here and change to like when you have two negatives, doesn't it change over to a positive? So you can switch it out.
Yeah, if you had a negative there.
If you had two negatives, there's one for A and one for B.
Okay. All right, so with this one, basically the same thing. Your rth root of x and your rth root of x, they have to be the same. And since this one's subtracting now, you're just going to subtract the outside numbers. You're not adding it. Okay? So, for example, what if we had something like this? What if we had let's do this.
So,
They're both square root of x, right? Now subtract the outside numbers. What do you get? It's negative 4 minus 3. Negative 7, yeah. You guys must be tired today, huh? So let's try this one. I'm going to give you guys one that's a little bit more involved, okay? Put a negative on the outside there. Negative root 32 minus 6 root 2. Let's try this. I think you guys can do this. You know, the square root 2, you can't simplify that anymore because 2 is already a prime number. You can't just go and subtract here because the radicals don't match. So I think you need to break down the 32, right? So let's do that. Let's break down the 32. Alright, so with this should be negative, because the negative was already out, right? Negative 4 root 2. Did you get that? Alright, minus 6 root 2. And what is that? Just 10? Negative 10. Negative 10 root 2. Good. Okay? Any questions? If you got that, great. Alright? That's perfect. That's great news. Let's go to our white sheet. And you know what, guys? I think you could do 5 and 6. Try it. Number 5, I think you need to break down both of them. Number 6, you need to break down both of them. Okay, so try this one. Alright, so with this, you guys should have broken down the 8 and the 50. Did you do that? No? Why'd you break it down? Oh no.
It gives you a decimal.
It does give you a decimal, then that means you need to do it the long way. Square root of 8. 8 is what? 4 times 2. 4 can be broken down into 2 times 2. How many do you need in a group to come out of a square root? 2, right? And then that's 2 root 2. Okay? Yes? We're coming back? So there's already a negative 2 on the outside, so you have to multiply that with the outside number. Negative 4 root 2. Okay? Minus, well, let's do square root of 50. 50 is 25 times 2. And 25 can be broken down into 5 times 5, and then 2. How many do you need in a group to come out? 2. So then this is 5 root 2. Did you already have something on the outside? No, right? So then it's just minus 5 root 2. Now you can subtract because your exponents and because your roots and your radicals are the same. Root 2. So what is that? What's negative 4 minus 5? But negative 9 root 2. Okay? Now let's break down 12 and 27 in number 6, because I can't just subtract them straight this way. The stuff inside the radicals are not the same. So if I break down 12, 12 is 4 times 3. 4 is 2 times 2, 3. This is 2 root 3. Right? Minus, well, 27 is 3 root 3. Okay? What's 2 minus 3? Negative 1. So you could write negative 1 root 3, or you could just write negative root 3. Same thing. Okay? And more likely than not, you'll just see it written as negative. Okay? You probably won't write the negative 1. Okay? Any questions? All right. So now let's go back to the purple sheet and let's look at multiplication. Okay. All right, so with multiplication, a couple rules here, okay? It's not like the adding and subtracting where the inside of the radical has to be the same. They could be different, all right? So the only major rule you need to know here is they need to have the same root. You couldn't, for our class, okay, you can't multiply a square root and a cube root together, all right? And here's the other thing. You can multiply your outsides together. See how it's A, B, right? And you need to multiply your insides together. So outside times outside, and then inside the radical times the inside of the radical. You can't flip-flop. You can't multiply outside times inside, okay? All right, and the other thing, actually, that is pretty important is I want you to follow something called SMS. Okay? SMS, which is simplify. We simplify our radicals first. That's breaking it down, right? And then we multiply. And then we simplify again if we need to, okay? All right? All right, so, oh, and this. I squared. What is I squared? Try putting it in your calculator. What do you get if you put in I squared? Negative 1. That's the other thing I want you to know. I squared, so I times I, that's negative 1. Okay? So let's try an example here. If we had a 4th root of 2, fourth root of 2 times 3 fourth root of 8. All right, well, let me see. Can I simplify? Can I simplify? Can I break down this 2 so I can get a group of 4 that comes out? No. How about this 8? Can I? 8 is what? 4 times 2. And this would be 2, 2, 2. Oh, we only have 3. Can't get a group of 4, right? So no, you can't break it down. All right, so now then I have to do m, which is multiply. So multiply your outside numbers together and then multiply your inside radical numbers together. So outside, over here, basically I have 1, right? What's 1 times 3? 3. 3 on the outside. And then it's a fourth root, right? What's on the inside? 2 times 8, which is 16, right? Okay, so then now SMS, simplify again. That means you're simplifying this radical. This fourth root of 16. Can you simplify that? Put it in your calculator. See if you can get fourth root of 16. This is a nice non-decimal number. 2? Perfect. So that means I already had the 3 inside. 3 outside, and then this guy became 2. So then what's your final answer? 6. 3 times 2, which equals 6. Okay. So how about if we had square root of 3 times square root of negative 6? Now, and make sure you guys do this SMS thing, because on problems like this is where you could get it wrong if you don't simplify first, okay? So simplify. Square root of 3, can I break down 3? How about square root of negative 6? I can't break down the 6, but there's a negative inside a square root. What comes out? I. So I need to say this is, okay, square root of 3 times I square root 6. Now multiply. Outside times outside, so 1I, which is just I. Inside times inside, which is 18, right? 6 times 3. Now simplify again. So simplify the square root of 18. Square root of 18. 18 is what times what? Okay, then we have to break it down. 18 is what times what? 9 and 2. Break down your 9. 3 and 3 and 2. How many come out?
1, 3.
Good. So this is 3. 2 stays in. What do we already have outside?
So it's 3I.
3I.
3I square root 6.
Good. So this is 3I root 2. How's that? A little bit longer, right? Because you have to simplify first, and then you got to multiply, and then you have to simplify, right? But let's practice using our practice problems on the white worksheet. Okay? Let's try a couple of problems here. Let's do number 8 first. I think 8 was a little bit easier. So remember, simplify, multiply, simplify. So simplify. Okay, square root of -5. I can't break down 5 anymore, but there's a negative inside, so what comes out? Good. So this is I root 5 times square root of -125. I know an I comes out, but that 125 is pretty big, isn't it? All right, let's break down this 125. -125, so an I comes out. 125 is what times what? What is 125? Like, what are the two numbers that multiply to give you 125?
5 and no, that's 25.
Guys, what two numbers multiply to give you 125?
5 and 5.
25 and 5. Bless you. So then I have okay, this 25 can be broken down into 5 times 5, and then we have this other 5. Good.
So 5I root 5.
Good. So 5I root 5. Okay. Now multiply. Remember, multiply the outside times the outside. What is I times 5I? 5I, how many? Squared. And then what about inside the square root? What's 5 times 5? 25. Now, let's simplify again. So we have the 5 that comes down. Guys, what did I tell you I squared is? -1. Okay, so -1. And then what is the square root of 25? We get a nice, pretty number. 5. So what is that? What's 5 times -1 times 5?
Negative 25.
-25. Okay. All right, let's look at number 7. So number 7, we're still doing the simplify, multiply, simplify. And I want to look at each of these. So if I look at this first one, just the square root. I have a 3 inside there. Can I break down the 3? No. Look at this x. How many x's do I have in there? Just the 1. But this is square root. I need at least 2 of the same thing to come out. So can this x come out? No. So I leave the x. Look at the y. How many y's do I have? 2. Wait a minute. So square root y and y. I need 2 in the group to come out. So look at that. Y could come out of there. Right? And then that goes away inside. Do you agree? So on the outside here is now -4xy root 3x. Yes? That's just the first one. Now let's do the same thing for the second one. Times. All right, just the square root part of the second one. Okay? Now look at the square root of 4. What is the square root of 4? 2. So then, okay, the 2 comes out. Look at your x. How many x's do you have inside? 1. That can't come out. How about the y? 1. That can't come out. How about the z's? 4. So let's see. So I have z, 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 and I need 2 in a group to at least come out. And there's 1, and there's 1. So I actually have z squared that can come out. Do you agree? Come in. So then the z's go away there. Yeah? So then for this expression on the right, well, let's see. 2 times 2 times z squared, that's 4z squared. Square root xy. Okay? Now, I simplified. Now I have to multiply. Multiply your outsides together and then your insides together. So outside, what's negative 4 times 4?
16.
Negative 16. X, oh, can't multiply x with anything, so just x. Y, oh, z squared, okay. Right? I just multiplied everything on the outside. Now, on the inside. Three. Can I multiply 3 with anything inside? No. How about the x's? Oh, I have 2. So that's x squared. And then y. Good. Yes? So now I have to simplify my radical again if I have to, right? So I'm going to look at my radical. Okay. The 3. Can I take the square root of 3? Can I break it down? No. What about the x's? Yeah. I have 2 x's inside. That means I can take them out, right? Because I have 2, at least 2 in the group. But how about the y? No. So let's rewrite our answer. Negative 16. Now I have 2 x's here, so that's x squared. Y, z squared, root 3y. And that's my final answer for number 7. I know, it's a lot of work. I know. I promise you, it'll make your life a little bit easier if you actually do all those steps out, okay? All right, can you guys handle division? Can we just go over the rules then? How about that? We'll go over the rules for division, and then we'll finish the practice problems next time. And then we still have one more rule to do. So go back to your purple sheet, and we're going to look at radical division.
Oh, we're just going to do the 2 examples?
I think, you know what, let's see how much time we have.
We have...
I like the division, okay? Yeah. All right, so the division rule, basically what it says is, if you have a big radical and you have a fraction inside, it's the same as splitting up that radical and saying x on top gets its own small radical, and the y on the bottom gets its own small radical.
So
You could write it either way.
Is it constants interchangeable too?
Huh?
Is it constants interchangeable too? Like, you
Yeah.
do it either way?
Yeah. Yep. So the only thing that I would recommend is always simplify your fractions if you can. Okay, always simplify your fractions before you split up any radicals. And remember, you can always join the radicals. So, for example, if you had square root of 4/9, can you simplify this fraction, 4/9? If you put in your calculator, 4/9, and you hit math enter, enter, do you get a simplified form? No, you do not. So, just by looking at it like this, maybe I can't really figure it out. All right. Well, then maybe it'll make it easier for me if I split up my radical. So then I said square root of 4 over square root of 9. What is the square root of 4? 2. And what's the square root of 9? 3. So look at that. Square root of 4/9 is really 2/3. How fun. Alright, so example 2. What if we had square root of x cubed over 100? Well, I know I can't simplify x cubed over 100 because I don't know what x is, right? So then I'm going to break this up and say square root of x cubed over square root of 100. Right? What's the square root of 100? 10. And up on top, square root of x cubed. Can you simplify that?
Bx.
X, and then how many left over inside? Yeah, x root x. Good.
Over 10.
Any questions? Yep, x root x over 10. Questions? All right. Since we only have 3 minutes left, next time we'll go over the 2 problems for the division on our practice sheet. We'll go over rationalizing denominators, and then we'll do the rest of that, okay? You guys will have time in class to practice all of this, and before the end of next class, you're going to take a mini quiz, okay? All right.